to the sixth and final video in this introductory series on fractions. In the previous 5 tutorials, I've introduced the concept of fractions and then gone through very systematically the various arithmetic operations that one would do with fractions, and in particular I've always been dealing with fractions of integers, which if you've watched the tutorials on numbers, you'll know in essence we've been dealing with rational numbers. But as I talked about in that tutorial on numbers, the word fraction really means the ratio of any two quantities. They don't need to be necessarily integers. And so the things that we've learned in dealing with manipulating fractions can be applied to any kind of fractions, in particular fractions that may involve symbols. And when you have symbols appearing in mathematics, we often call that algebra. So in this last tutorial, I just want to give you some examples of applying what we've learned to the algebra of fractions. I won't be able to really cover this whole topic, but it's more of a confidence boost that I want to give you, that if you're comfortable doing arithmetic with fractions in terms of rational numbers, then you will be perfectly able to do algebra with fractions. So fractions continued, the last part of this introductory series, and we're going to be dealing with algebraic fractions. Algebraic, that's a slightly difficult word to spell, algebraic fractions. Now, just to start with, let's quickly remind ourselves of the things that we have learned. So, for example, we're comfortable that if we have a fraction that involves a common factor, like 6 over 8, we could write as 2 times 3 over 2 times 4. We're comfortable cancelling out a common factor and simplifying a fraction. We learned about multiplying fractions. So, for example, 2/3 times 3/5, for example, we would have 2 times 3 is 6 over 3 times 5 is 15. I'm not going to bother simplifying that for now. It's more the operation of multiplying the tops, dividing by the multiplication of the bottoms or the denominators. We've talked about dividing fractions. So, for example, 2/7 divided by 2/5. Then the idea is that you turn the division into a multiplication and you flip the second fraction here. Do the multiplication, and again, of course, that could be simplified, but that's not the focus right now. And then in the last couple of tutorials, we've talked about adding and subtracting fractions. I'll just do a quick example of adding 1/4 plus 1/5. The idea of cross-multiplying. So 5 times 1 is 5, 4 times 1 is 4, over the product of 4 times 5 is 20, gives us 9 over 20. So that brief little summary of the arithmetic that we've been learning, now wanting to apply that to algebra, where we might have some symbols around. So, for example, imagine that you were doing some algebra and you might have something like 2y divided by 4 as a fraction. And here, this would just be an example of simplifying a fraction. I can write this as 2 times y divided by 2 times 2. I have a common factor of 2 on the top and the bottom, and this simplifies to y over 2. We might have an algebraic problem where we have two fractions being multiplied together. So let's see, I'm just going to make up an example here. Imagine I have 2 over x multiplied by a over 3. And don't worry what x and a are. They're just symbols that might appear in some algebraic problem we're asked to do. So I just can't emphasize enough not to get hung up on the fact that these are symbols, but just to boldly go forward with the arithmetic operations that you've learned from the last few tutorials and just follow the steps that we've learned. So we have a fraction multiplied by a fraction, so we multiply the two numerators together, divided by multiplying the two denominators together, and we would then write this as 2 lots of a divided by 3 lots of x, and that would be the answer. Let's look at a division example. Imagine we had x over 4 divided by, let's say it was y over b. Now this might actually come from something rather scary. This might actually come from something which looked like x over 4 divided by y over b, which would strike fear into the heart of many budding mathematicians. But again, a fraction divided by a fraction, you're perfectly within your rights to just write it in this simpler form of, okay, that's the first fraction divided by this fraction, and then to feel very comfortable saying, right, when you divide a fraction by a fraction, I take the first one, I multiply then by the flip or the inverse of the second fraction. So that would then be b over y. I then have a fraction multiplication problem. I have the two tops multiplied together, so that would be xb divided by the two denominators multiplied together, 4y, and that would be the answer. So I hope you're beginning to see that really there's nothing terribly fearful about these algebraic operations with fractions. We just follow the rules that we've already learned. I would like to just introduce one aside here, because when I spoke about dividing with fractions, I didn't really give you a conceptual basis for why we do the thing that we do, namely that we turn the division to a multiplication and then flip the second fraction. And in all of these tutorials, I never want you to have to take anything on trust from me. I want you to be comfortable that I've explained things and that you can really feel that this is a piece of truth rather than just some ad hoc rule that's coming down from some mysterious tutor. So let's just see why that is the case. And really it comes from the following. We know that if you, so this is an aside here, we know that if you divide anything by itself, then you have the number 1. So for example, 2/3 divided by itself has to equal 1. But we also know that 2/3 multiplied by 3/2 would be equal to 2 times 3, which is 6, divided by 3 times 2, which is 6, which is also 1. And so we see that 2/3 divided by 2/3 is actually the same as 2/3 multiplied by 3/2. And so essentially this shows you very clearly that when you're dividing by a fraction, it's equivalent to multiplying by the inverse of that fraction. So dividing by 2/3 is the same as multiplying by its inverse, which is 3/2. And that's the conceptual sort of nugget of why that operation is true when you're turning a division problem with fractions into multiplying by the flip or the inverse of that second fraction. Let's imagine we were adding some algebraic fractions. So 2 over x added to, let's say, x squared divided by y. And again, I know from my teaching that for many students this just looks really a scary sum to do, because they might perhaps say, well, I don't even know what x and y are, how can I possibly manipulate this? And I think the point really is that in algebra, the symbols in a given application may have a meaning, but when you learn algebra, you're really learning a set of skills that enables you to manipulate symbols so that you can simplify them. And we would like to turn this into one fraction, and so we can go about it using cross multiplication. That's probably the fastest way. So we're going to take the denominator of this fraction upstairs and multiply it. So we have 2 times y. And then we're going to take this denominator upstairs here and multiply it. We have plus, and then we have x multiplied by x squared all over the product of the denominators, x times y. And I can just manipulate this a little bit. So I have 2 lots of y plus x times x squared is x cubed. If that isn't quite clear, don't worry, I will be giving a tutorial on indices and powers in a short while, and you'll be very comfortable with things like x times x squared is x cubed, and the denominator is xy. And this would be the answer. You might think, well, how is that the answer? But really the point was to try and convert this into a single fraction, and this is the single fraction. And there is no way to simplify this any further as a single fraction, because there is no way that we can factorize the numerator to possibly cancel with anything in the denominator. So that's the answer. And I'll just do one more example. I'll try to write something down which looks really quite horrible, and then we'll do it in a couple of steps. So imagine I had a fraction of fractions which was algebraic. So let's imagine I had a over 3 divided by 4 over b. That looks pretty horrible. Take away a over b. So I just made that up, but it looks rather nasty. We'll do it in steps. We have to deal with this first one. It's the division of 2 fractions. So it's a over 3 divided by 4 over b. And then once I've worked this out, I have to subtract a over b. Now I'm going to convert this to a fraction multiplication. So it's a over 3 times, and then I flip that second fraction, b over 4. And then again, once I've done this, I need to subtract a over b. Notice it's very important to get the operations in the right order. I have to deal with this bit first, and so I'm just writing take away a over b to remind myself that once I've dealt with this mess, I can finally subtract a over b. Multiplying these 2 fractions together, I have on the top a times b, on the bottom I have 12. And then I'm subtracting a over b. Now I'm going to cross multiply, so I take the b upstairs, I take the 12 over to there, so I have ab times b, which will give me ab squared, and I subtract from that 12a. This comes up here and gives me 12a all over 12b. And probably as a final step, I could just factorize that a in the numerator to make it look a little neater. So I might want to write this then as a into b squared minus 12. So I'm just factorizing by a all over 12b. So a rather horrid example to finish this tutorial, but hopefully one that you could follow just to show that really no matter what the problem throws at you, or in some cases the examiner, if you have exams looming in the future, just taking a step-by-step approach with a cool head and remembering your arithmetic rules for manipulating fractions, you'll be able to see your way through fairly straightforwardly. So we have done with fractions, at least for the time being, and I will be turning my attention now to other topics at this sort of level of mathematics, such as the equation of a straight line, dealing with surds, trigonometry, quadratic functions, and so on and so forth. And I look forward to seeing you for those topics if you have found these tutorials helpful so far. So I'll see you next time.